Great. So we are moving into conditional probabilities and multiplication rule. So multiplication rule applies to and events. So this is mostly going to be focusing on these and events. And events are where we have to have two things happen at one time for the event to have occurred. So you tend to use and events naturally all the time without realizing it. So approximately 50% of adult males are over 6 feet tall. So if we select a man at random from the population, there is going to be about a 50%, not 50, sorry, a 15% chance or 0.15 probability that they're actually going to be over 6 feet tall. So let's assume now that you have a little bit of additional information about this man. So we select this man, and now we find out not only is he a man, but he's also a professional basketball player. So now that we know they're a professional basketball player, their odds of being over 6 feet tall actually increase. Also, like if we told them we knew they were a jockey, their odds of being over 6 feet tall actually would decrease. So additional information could change that odds of 15%. With this extra information, like I said, the probability this man is over 6 feet tall is significantly greater. The probability that's computed with knowledge of additional information is what we call a conditional probability. In a conditional probability, the occurrence of one event affects the probability of another event. So just looking at men in general, we know there's a 50% chance that they're going to be over 6 feet tall. But if I add on another event to that, so not only is it they're a man in the US, they're a man in the US, also they're 6 feet tall. Or sorry, also they're in the NBA. Said that wrong. If they were 6 feet tall, then that probability is 100%. So conditional probabilities are written like this. A conditional probability of an event A given an event B given an event A is denoted as this P. And then we have B, and it's not a slash, it's like a horizontal line, A. So I have a tendency people look at this and think of it as like division. This is not division. This little sign here just means given. So it's just telling you, we want to figure out event A, its probability, given event A is also have occurred. So the probability of B given A is the probability that B occurs under the assumption that A has also occurred. So when we compute these probabilities, and this makes it make it look more like we're talking about a quotient, kind of are, just not the way it looks. But this is really just the probability of A and B over the probability of A. So for a select man, a randomly selected man, the probability of being over 6 feet is actually 0.15, like we said before. However, the probability that a randomly selected man being over 6 foot tall, given we know he's in the NBA, is actually 0.98. At least that's what I looked up. So probability that they are 6 feet tall, given you're in the NBA, as the probability that this person is 6 foot tall and in the NBA or an NBA player. And this is compared, because we're saying given NBA, compared to NBA players. So we want to look at what's the probability that you are in the NBA first. And then once we know you're in the NBA, what's the probability that you're 6 foot tall? So I actually don't know the probability of being just in the NBA and being 6 foot tall and in the NBA. These are like two different probabilities. This is just the one that I could find. Okay, so for an example, we're going to kind of baby step our way through this. The following table represents the number of US men and women in millions who are 25 years and older and have attained various levels of education. So suppose that a person is randomly selected. We want to know, what is the probability that a randomly selected person is a man? So you'll get these charts a lot. And this is telling me that I have 14 million men who are 25 years and older who have not graduated high school. Here I have 7.2 million men who are 25 and older who have attained associate's degrees. So remember, these are all in millions of men. So if I want to figure out that probability of randomly selected person is a man, one, I need to know two things. I first need to know how many men are there. So if I add all of this up, I'm going to get 94 million men are in my study here. So that gives me part of what I need to know. What's the probability that a randomly selected person is a man? 94 out of what? So not only do I need to know how many men do I have, I need to know how many total people are in my study. So that requires that I also figure out how many women are in my study as well. And if I add that up, I get 101. So what I find out is I have 195 US adults 25 or older. So that is my total of my population. So that was my population size. Okay, I believe this was 49%, but I just want to double check it. Yeah, so if I say round out the 3 decimal places, that 49 is 48. This is roughly 48.2% of this population of 25 and older are going to be men. So actually this does make sense because as the population gets older, there tends to be less males and more females. Younger populations tend to have a higher percentage of males. And we're looking, like I said, 25 or older. Okay. This just tells me straight off, like, what's the probability that somebody's a man? Well, it's about a 48% chance that they're going to be a man. Okay. Well, let me get rid of this because we're going to have another part to this question here. Don't need that in my way. So we're working our way to a conditional probability. We're just taking baby steps. So this is a little slightly different question. What's the probability that a person is a man with a bachelor's degree? So right here, these are my men with bachelor's degrees. So this is the event of a man and they have a bachelor's. So what this probability is asking me, if I'm looking for a man with a bachelor's degree, I am looking for a man and they have a bachelor's. So that probability is I have 17.5 out of my total of 195 people in my study. And this is going to be 0.08. Actually, it's going to be 90 if I round it to 3 decimal places. So where we had a 48% chance that a randomly selected person is male, we have a 9% chance that a randomly selected person is male and they have a bachelor's degree. And just for comparison, if you compare this to the women, we have like about a 10% chance that a randomly selected woman would have a bachelor's degree. So they're close to each other. So you're going to see this through these probabilities that they're very close to each other. Since it's about half men and half women, I would expect half the men to have bachelor's degree and half of them to have associate's degree, or half of the women have, sorry, half of the bachelor's degree to be men and half of them to be women. So I'm going to do some adjusting here. So in this case, we want to figure out what is the probability that a randomly selected person has a bachelor's degree given that he is a man. So if you remember my formula for a given event, B given A, as a probability of B and A occurring. And this is divided by the probability of just A occurring. So we're going to see here what's really telling us, but we're looking at this one. So we're looking at the probability of having a bachelor's degree given that the person is a man. Okay, so a man with a bachelor's degree, we know that's going to be 17.5 out of 195. So remember, this is actually man and bachelor's degree as well. And this is divided by the probability that they are a man. The probability of B and A over the probability of A. The given event is always going to be at the bottom. So we have this, the 17.5 or the 195. A probability of a man is 94 over 195. This and this cancel. And what I'm really left with here is actually 17.5 divided by 94. And what that's going to give me is 0.1862. So about 19% of, what does it tell me? 19% of men have bachelor's degrees. And once again, just for comparison, if I do this with women as well, so I got to fix a number here. Women also are about 19%, so it's slightly higher than men, but it's about the same. But like I said, there's slightly more women in the population than there are men there. So conditional probabilities, like I said, the conditions that they tell us we have to pay attention to. So this is the probability of a man with a bachelor's out of men. If you go back and look at this, my bottom number was just looking at the men. So really what I'm looking at is I'm looking at men, and I want to know what percent of the men have a bachelor's degree is what I really asked you here. Okay, so we're going to do this a couple more times, but one of the things I said here is that, you know, we're noticing that this is all roughly about 50-50, because half our population is men, half the population is women. So half of those without a high school graduate are about men, about women. About half of men are going to have a high school out of high school graduates, about half of men. Out of some college, about half of them are men. Out of associate degrees, about half of them are men. The probabilities change a little bit, but generally it's almost about half of it is men. So this is not something that we always see with conditional probabilities, because here you're kind of going, well, what's the point of doing the condition? So the following table represents the number of U.S. men and women, once again, age 25 and older. But this time we're going to start looking at women and high school graduates. So we're going to put back some of our numbers here. So what is the probability that a person is a woman who has a who's a high school graduate? So we're looking at women and high school graduate. So if we go back here, we look, we have 31.9 million out of 195 million people are going to be women who graduated high school. The probability that if I randomly selected from this whole population, that what I grab is a woman who has at least has a high school education only, that is going to be, there you go, about a little over 16%. So out of the whole population, about 16% of them are women with high school educations. What is the probability that a person is just a high school graduate? Well, that requires me to figure out the total number of high school graduates. So if I add up the men and women who graduated from high school, I should just calculate this, but I just lost my calculation. That is 61.5 million people. So out of my 195 million people, 61.5 million have graduated high school. And this is almost a third of my whole population are just high school graduates. So the next question, we got to pay attention to what part's the given. What is the probability that a person is a woman given that the person is a high school graduate? So we're looking for woman given high school. So what I'm really looking at is what's the probability that if I look at just high school graduates that I'm finding women. So this is women in high school over the probability they're in high school. So you could use the decimals if you wanted to. That's going to give you kind of a rounded answer there. Or we can just use the 31.9 out of 195, the 61.5 out of 195. We know that's just going to turn into 31.9 out of 61.5. And that's going to be almost a half. So almost 52% of high school graduates are women. So my conditional probability is just telling me that, let's try that again. Like I said, roughly 52% of high school graduates we'll phrase that just a little differently. 52% of people with just a high school education, and I can get more technical than this, but we're not going to. But this is a important distinction because it's not just high school graduates, it's people who just graduated high school and that's all they did. 52% of the people who just graduated high school are going to be women. All right. So like I said, we're not getting anything too astounding out of this. That's kind of what we expect, right? We expect half my high school graduates to be women, half my population is women. But sometimes the conditional probabilities give us much different probabilities than we expected. So for an example here, we're going to use the data from the Titanic. So we're just looking at classes. If you look at it by gender, you're going to see like completely different statistics for men surviving and women surviving. Classes, we're going to see something different as well. But we don't know exactly how many people were on that Titanic, but what we can calculate from what we do know is that about 2,223 people were aboard the Titanic when it sunk on April 4th, 1912. The chart below shows how many survived and how many people survived and how many were lost, and it's divided by classes. So we want to know, what is the probability of surviving the sinking of the Titanic? So this one fortunately has some numbers on it. So the number of survivors that we have for the Titanic is 706 people out of the 2,223 survived the sinking of the Titanic. So the probability of simply you just survived, if you were on the Titanic and you survived, it's just about a third. Let me go find that number again. There's too many things that are about thirds. 0.318. So roughly a 32% chance that if you were on the Titanic that you would have survived. Those are not great odds. That means a third of the people survived the sinking of the Titanic. However, depending on what class you're in, your odds changed a little bit. We want to know, what's the probability of surviving the Titanic given you were in first class? So probability you survive given you're in first class. So remember, this means I need the probability of survive and you were in first class, which we have right there. And this is going to be over the probability. So remember, this is what goes in the bottom, probability you were in first class. So survive in first class, we have 199 people were survivors in first class out of my 2,223 passengers. How many people are in first class though? That was 329 people out of 2,223. So really what we're looking at is we're just looking at first class, and we're looking at how many people survived who were in first class. Anyways, what we get here is going to be 199 divided by 239, and this is going to be 0.605. So there was a 60% chance of you surviving if you were in first class. That is much different than this 32% that you get of just simply surviving. So this is probability of surviving if you were in first class. And to kind of give you a better perspective on this, first class took about 15% of the total number of people aboard the Titanic, but their survival rate was much higher. So like I said, 15% of the people aboard were in first class. So this is telling you that there was like your class had a significant impact on your survival rate. Now, if we do third class, the probability of survive, given you're in third class, change my color here a little bit. Let's do pink. So we're really just looking at this part here, because what this is going to be is that this is the probability of surviving and being in third class. And remember, because third class is the given, this is over third class. So what we have is 179 people were in third class out of 710 people. So I just didn't even bother with the 2,223 because I know it cancels out. So this is roughly about 25%. Let me get an exact number for that. So about 25% of those in third class survived. So this is surviving if you were in third class. And once again, what percentages of the total of the crew? Like you see, there's almost like twice as many people who are in third class. Sorry, got the wrong number here. So we have roughly about 32% of the people are in third class. So when you look straight at it, at the numbers, what you're seeing here is it looks like about the same percentage or about the same number of people in third class and first class survived. But really, when you look at the actual statistics, the conditional probabilities, your chances of survival were much different. So where we might have almost, like I said, the same amount of people in third class and first class survived, if you were in first class, though, you had a 60% chance of surviving. If you were in third class, you only had about a 25% chance of surviving. So this is where conditional probabilities really stand out, is that if you look at just the statistics of surviving was like 32%. However, it's very dependent on the class you're in. If you were in the lowest classes, or also the crew is very close to this, the crew is about 23%. If you were in that third class or part of the crew, you know, your chances of survival were much less than if you're somebody get in the first class. Second class is almost 50%. So we see here that class has a high 42%. Class has a significant impact on your survival rate here.